When partitioning a system into a collection of cooperating classes, there is a need to maintain consistency between related objects. You don't want to achieve consistency by making the classes tightly coupled because that reduces their reusability. For example, many graphical user interface toolkits separate the presentational aspects of user interface from the business logic and data. Classes defining application data and presentations can be reused independently. Both a spreadsheet and a chart can depict the same data using different presentations. The spreadsheet and the chart don't need to know about each other, but they behave as they do. Changes in the information are reflected immediately in the spreadsheet and chart and vice versa. This behavior implies that the spreadsheet and bar chart are dependent on the data object and therefore should be notified of any change in his state. An observer defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. Use the observer pattern in any of the following situations. When an abstraction has two aspects, one dependent on the other, encapsulating these aspects in separate objects lets you vary and reuse them independently. When a change to one object requires changing others, and you don't know how many objects need to be changed. Or when an object should be able to notify other objects without making assumptions about who these objects are. In other words, you don't want these objects tightly coupled. The observer pattern describes how to establish these relationships. The key objects in this pattern are subject and observer. A subject may have any number of dependent observers. All observers are notified whenever the subject undergoes a change in state. In response, each observer will query the subject to synchronize its state with the subject's states. This kind of interaction is also known as publish-subscribe. The subject is the publisher of notifications. It sends out these notifications without having to know who its observers are. Any number of observers can subscribe to receive notifications. The structure includes a subject that knows its observers, and any number of observer objects may observe this subject, and provides an interface for attaching and detaching observer objects. The observer that defines an updating interface for objects that should be notified about the changes in a subject, a concrete subject that stores the state of interest to concrete observer objects and sends the notification to the observers when the state changes. And there is also a concrete observer that maintains a reference to a concrete subject object, stores states that should stay consistent with the subject's state, implements the observer updating interface to keep the state consistent. The concrete subject notifies all the observers whenever a change occurs. After being informed of a change in the concrete subject, the concrete observer may query the subject for information and then uses this information to present and ensure that it has the correct information. Subjects and observers can vary independently. It is possible to reuse subjects without reusing their observers, and vice versa. It lets you add observers without modifying the subject or other observers. Further benefits and liabilities include: all a subject knows is that it has a list of observers, each conforming to the simple interface of the abstract observer class. The subject doesn't know the concrete class of any observer. Thus, the coupling between subjects and observers is abstract and minimal. Unlike an ordinary request, the notification that a subject sends didn't specify its receiver. The notification is broadcast automatically to all interest objects that subscribe. This allows freedom to add and remove observers at any time. It is up to the observer to handle or ignore a notification. And finally, since observers have no knowledge of each other, they don't know the cost of changing the subject. And this is a liability. A simple operation may cause a cascade of updates to observers and their dependent objects. Dependency criteria might not be very well defined and can lead to not needed updates. The first and perhaps best known example of the observer is the pattern that appears in Smalltalk named Model View Controller, MVC. The model class plays the role of subject, while view is the base class for observers. Any other dependents or published subscribers are also included in this pattern.